Okay, section 2.2, number 17, and it says use the rules of differentiation to find the derivative of the function. So our function given is s of t equals, t cubed plus 5t squared minus 3t plus 8. Okay, so the derivative of our function will be the derivative with respect to t of this quantity, t cubed plus 5t squared minus 3t plus 8. We know from the sum rule that this can be broken up at any functions that are added or subtracted from one another. We can take the derivative of each term individually, right? So if we take the derivative of this first term plus the derivative with respect to t of the next term, here we have a minus, so minus the derivative of this next term, and then plus the derivative of our last term, we get the same thing as the derivative of this. So the derivative of t cubed, we can use the power rule, bring down the 3, subtract the exponent by 1. In the next one we have the constant multiple power rule, which states that if we have a constant multiple times some value that we know what its derivative is, we can bring that constant multiple out. So we can bring out that 5 and then use the power rule. One moment. Keep hitting that button. Let's see. Erase that. Okay. We can bring down the 5, or excuse me, bring down the exponent of 2 and subtract the exponent by 1, so 2 minus 1 is 0. Okay, so then this, constant multiple rule again, but this time our exponent is 1. Bring down the 1, subtract 1 minus 1, which is 0, so t to a 0 is 1. So that's minus 3, and then the derivative of any constant is 0. So this is what our derivative is equal to. Oh, we can simplify this a little bit more by saying plus 10t minus 3. And that's number 17. So let's look up what our next one is. Okay, our next one is problem number 33, and that says find the slope of the graph of the function at the given point. Use the derivative feature of a graphing utility to confirm your results. And I don't want to do that. I want to find what the derivative is and do things the manual nice and hard way. Alright, so number 33 is this. So let us use our knowledge of the sum rule and the power rule to figure out what the derivative is of our function. So the derivative of negative 1/2 is 0. The derivative of 7/5 x cubed is going to be, we bring out the 7/5 as a constant multiple, bring down our power times 3x squared equals 7 over 5 times 3x squared. So that is going to be equal to 21 over 5 times x squared. Okay, so that's what our derivative is equal to. So what we want to do is we want to find out, so our function, they want to know, so our function is going to look like something. Let's see if I can use, hold on one moment. Okay, let's actually use a graphing calculator for this, right? So I'm going to go online to gcalc.net, and then I went to this, and then I have a little thing says click to start, and I'm going to try starting gcalc 3. It says a little graph plugin right here, right? And then when I double click this, it gives me this little graph thing right here, and I'm going to input my function into this, and my function is negative 1 over 2 plus, let's see, what did I say, 7 divided by 5 times x cubed. And hit graph, and there's our function, right? So I want to figure out what my graph is equal to for a value of x that is right around here, or equal to 0, right? So my point of 0, negative 1/2, which is right here, right? So my graph looks like this. From my graphing calculator, comes up, and then it comes back up again, right? Okay. And at a point right here, I want to plot my derivative. So I put in the value of my derivative, f prime at 0 equals 21 over 5 times 0 squared, which equals 0. So the slope of my derivative is equal to 0. 0 means that I have a horizontal line, right? So my derivative is equal to a horizontal line that passes through 0, negative 1/2, which, if we wanted to plot it on a graphing calculator, I should have it like this, would look just like that, right? And it would be equal to negative 1/2 equals y2 on your graphing calculator, and this function, y1, would be equal to negative 1/2 plus 7 over 5x cubed, right? And so you would plot these two, and you would get the answer to number 33. All right. Let's see. I wonder if we can do this, and it would, let's see, negative 1/2 graph. Yep. There it is, right? Okay. So let me see, plug in. I wonder if you can clear it. No? Nothing? I don't know. Alright. So let's do the next couple in another video.